All right, in this video, I'm going to show you how to calculate the optimum portfolio weights and then use those weights to calculate the Sharpe ratio, which we call the Sharpe ratio for an optimum portfolio. In this case, we have two stocks and you are given covariance matrix, you are given risk-free rate, and then you are given a rate of return on each of these stock. Okay, so first of all, let me explain how to read this covariance matrix. So this is a covariance matrix. In this covariance matrix, you can see that we have stock X and Y, and here X and Y. So this one, this box here, this one is the covariance. This is the variance of stock return for stock X. Okay, so this is the variance of stock X, variance of returns of stock X. This one here in D7, this is the variance of stock Y. Once again, this is in C6, this is the variance of stock X return, and this one is D7, this is the variance of returns of stock Y. And here, this one C7, this one is the covariance of the stock returns X and Y. Okay, so I have given the arrows so that it's easy to understand. All right, so the goal here is to find out the Sharpe ratio of an optimum portfolio of two stocks. Okay, so for that I need to solve a lot of problems here. I need to find out the expected return for the portfolio, variance for the portfolio, standard deviation for the portfolio, and then I can do Sharpe ratio. So to understand that concept, first of all, we need to look the formula for the Sharpe ratio. Okay, so Sharpe ratio equals to a return on the portfolio minus risk-free rate that divided by portfolio risk. Okay, so that is the reason we need to calculate all of them. So I'm going to use two approaches. The first approach, I'm going to use Excel, which is the very easy approach. And the second approach, I'm going to use a formula. Okay, so the formula for the weight calculation for two assets is this one. So this is the formula I'm going to use. All right, so let me start with Excel. So first of all, I'm summarizing this problem here. So I need a risk-free rate of return later on, and everything else is summarized over here. Okay, so I'm gonna start the portfolio weight with 50%, with 0.5, which is a 50% for each of these stock. Okay, so I'm gonna start with 50%. And remember, we cannot have more than 100%. Okay, so we're gonna start with 50% and then use those numbers, okay, to calculate the weights and then the Sharpe ratio, and later on we're gonna optimize. Okay, so let me take out all of these numbers here. All right, so I'm gonna start with 50% in stock X and 50% in stock Y. So total I'm gonna have is only 100%. So that value is gonna be 1. So let me start with the calculation. Okay. All right. First of all, I'm gonna calculate portfolio return. As you know that portfolio return equals to the weight times the return of each of these securities. So I'm gonna start with weight 50%. Remember, right now I'm just doing the regular calculation. I'm not optimizing. So weight of the first stock times the return of the first stock plus weight of the second stock times a return of the second stock. Okay, which we call portfolio return. All right, you can put in percentage and you can round up to 2 decimal. That's your choice. And you can see what I did over here. All right, The second thing I'm going to do is calculate the variance using this formula. Okay, so I'm going to follow this formula. So I'm going to do WX square, means the proportion I'm investing in stock X, which is 50%. So I'm going to do 50%. I'm going to do the square of that number times the variance of stock X, return, this one. Okay, I'm going to do plus, follow the formula. I'm going to do the weight of the second stock, that's going to be square, times variance of stock Y, which is variance of return on stock Y. Right here it's given. All right, so first and second part, and the third part I'm going to do plus 2, that comes from the formula, and the weight of the first stock, which is 50%, times weight of the second stock, okay, times covariance. So where do you find the covariance? Let's check in the covariance matrix. So this is the covariance. All right, so we got the variance. All right, we have the variance over here. At least I want you to have 5 decimal, okay, on this one. Okay, this is the variance of your stock return, variance of your portfolio return. All right, now let's calculate the standard deviation, which is SQRT, and then I'm going to take that number and do the square root. So 9.23%, that's going to be the square root of the variance, which is the portfolio standard deviation. Now let's calculate Sharpe ratio, which is the return on the portfolio. Remember to put parentheses, because the top part, the numerator, is portfolio return minus risk-free rate. Okay, here is the portfolio return minus the risk-free rate is 2.78%, and then I'm going to divide by the standard deviation of the portfolio return. Okay, now I got 90.9989. That's the Sharpe ratio. Okay, so step 1, find the Sharpe ratio using 50% investing in each stock. Step 2, use the Excel solver to optimize. That's going to be your answer. Okay, so first of all, we calculate the Sharpe ratio. Second, we're going to use Excel solver. How do you do that? You click on data. What do? You click on data tab here, as you can see. Then you're going to see here. If you don't see the solver, you need to install that solver in your Excel. I want you to go to File and go to Option, and you can see here Add ins, click on that, and then from here you can select solver add in. Okay, you double click, and here you go. Okay, and then you make sure you check in. Okay, make sure you check in, then okay. In my case, I have already done, so I don't need to do that. Okay, right? One more time. You're gonna go to File, Option, and you click on Add ins. You double click this one, and here you're gonna click on Go, and make sure this one, if it's unchecked, make sure you check in and do okay. If you still don't see this one, you just close your Excel file and then reopen your Excel file. You will have this solver. All right, we solved that problem. Now we have the solver. So what I'm going to do is I'm going to optimize the Sharpe ratio, changing these two numbers, which are the percentage. What percent I'm going to be investing. All right, so let's click on the solver. And since I already have used this one, I have these numbers here. So I'm going to remove all of those numbers and restart. Okay. And let me delete this one. All right. So now I have the clean solver. So here, set the objective. What is our objective? Our objective is maximize the Sharpe ratio. So I'm going to click that Sharpe ratio in D26. We calculated using 50% on each of these stocks. I'm going to make sure I'm going to select max, not the minimum. I'm going to select the max. And then third important point here is what you're going to be changing to maximize. We're going to be changing these two numbers, percentage or the weights, right? So we're going to change these two things. What are we going to be changing? We're going to be changing the weights. Okay. All right. So we select these D21 and E21. Those are the percentage we're going to maximize. We're going to optimize. And I'm going to add the constraint. The constraint condition over here is the total, the sum of these two weights is going to be 100%, which is equal to 1. Okay, so I'm going to put that constraint, add that constraint. Okay, all right, I add that constraint. Now everything else is fine. All I need to do is solve it. Okay, let me click on the solve. Here you go. And it's going to ask you, do you want to keep the results from solution or you want to restore the original value? And our goal is to use the optimized value. So I'm going to click OK because it's already selected keep the solver solution. All right. If you round up this number to 2 decimal points, if you round up your number in 2 decimal points, let's do that. It's 1.01. That's the solution for this question. Okay, what is our question? What is the Sharpe ratio of an optimum portfolio of 2 stocks? Two assets, stock X and Y, right? And this is the solution. Well, if you are not comfortable using Excel, and as you can see, I have given all these like formulas over here, okay? So you are already familiar with this formula. If you are not comfortable using Excel, I have the solution for this question using the formula, okay? So, all right, let me start the same question, but this time I'm using a formula. This is the formula for calculating weight for stock with risk, 2 stocks portfolio with risk-free return. All right. So in this case, this is the weight of first stock, and then this is the weight of the second stock. So in our earlier solution, we put 50% on each of them, right? 0.5 on each of them, and we solve the problem. In this case, I'm not gonna put 50%. I'm gonna solve this equation using this formula. Okay, so first I'm gonna put all the information here and solve it, because you might make mistake if you try to solve everything here. So one at a time, the top part, numerator and the denominator. Okay, so I'm going to start with the top part. Equal, I'm going to have return of asset X and then minus risk-free rate times the variance of stock Y, and so on and so forth. Let me just select those numbers. Equal, so I'm going to start with parentheses. I'm going to follow exactly what is here in the formula. So where is the return of the first stock? Return on the first stock is right here, minus RF. Where is RF? Right here. All right. And then multiplication sign, the variance of stock Y. So return of stock Y. All right. Then what do we have in the formula? Then we have the minus sign, and then we have parenthesis and return of stock y minus risk-free rate of return. Risk-free rate of return. I'm gonna closing the parenthesis and using the multiplication sign. Okay, and then I have the covariance of stock X and Y. Covariance of stock X and Y, which is right here. All right, I got the top part. I'm not going to use percentage here. Okay, I'm going to just use the number, a number, and I'm going to be using at least 5 decimal points. All right, I got the top part, numerator. Okay, now let's calculate the denominator. So again, I'm going to start with the parenthesis. Okay, so this is a big number. Okay, so we have to do everything very carefully. Return of X, which is right here. Okay, so here you start with the equal sign and the parenthesis, and a return of the first stock, which is X, this one, minus RF, risk-free rate. And then we're going to multiply with variance of stock return Y. Okay, variance here, right here. All right, then what do we have in the formula? Then we have the plus sign, and then we have parenthesis, and we have return of Y. Return of Y is right here, minus risk-free rate of return further. So risk-free rate of return times, I'm going to multiply with the variance of stock X return. Okay, right here. And what else we have? Then I'm going to do minus. Okay, then I'm going to do minus. In that minus is, so we're going to have two brackets. So here is the big bracket. So I'm going to use one bracket and then the second bracket for the formula here. So return on X, which is return on X, then minus, I have the risk-free rate of return. Okay, parenthesis. Remember, we have plus sign here. So we're going to use plus, and then we have RY, which is return on the security Y. Then we have minus RF, then we close the parenthesis, we close the whole thing, and then we're gonna multiply by the covariance. Okay, we're gonna multiply by the covariance. Covariance is right here. All right, let's check this one. Everything looks good. So we have this parenthesis, we have everything we put right. So I'm gonna enter, and again I'm gonna format, I'm gonna put a number, and I'm gonna put 5 decimal points over there. Okay, all right, I calculate these numbers and I format it. All right, so let's calculate the weight of, so let's get the final answer. So weight of, this is weight of X, that equals to, we divide the top number by this bottom number from the formula, and that's a 55.57%. Okay, so if you have 55.57% in stock X, you're going to have leftover. You're going to have leftover value over here. So from 100%, so 1 minus this number, that's going to be the weight for stock B. Stock Y, stock X, you're going to put 55.57%, and leftover you're going to put on the second stock. This is how you're going to be manually calculating the portfolio weight, okay, using this formula. Now, using this formula, we're going to calculate the Sharpe ratio. So first of all, I'm going to, so here you don't need to worry about the weight, but still I'll show you, if you add these two numbers, it's going to be 100%. Okay, if you have $10,000, you're going to put 50,000%, 55%, 55.57% in stock X, and that leftover is in stock Y. So total investment you have is 100%. Okay, so one is 100% because these numbers are in decimals. Okay, all right. A return on portfolio, same like we did earlier. So weight of first stock times a return of the first stock, which is right here, plus weight of the second stock times a return of the second stock. Okay, so we put those, and we got that calculation, and I want to put in 2 decimal. All right, the variance of the portfolio. Again, I'm going to use this formula, so which is equals to weight square. I'm going to multiply with the variance of stock X return, so which is right here. Okay, I'm going to come down, I'm going to follow the formula, plus weight of the second stock square. So this one I'm going to do square, and then multiply by the variance of the second stock return, which is right here. Okay, I'm going to come down the formula, and I can see there is a plus sign, and then we have 2 multiplication W1 WX times WY times covariance of XY. What is covariance? It's given in the question. This is the covariance. Okay, let me check, make sure we put all these numbers. Okay, we put all this information using this formula, and then we enter. So this is the variance. I want to put 5 decimal points. Okay, so you can see clearly. Now, how do you calculate portfolio standard deviation? You just take the square root of SQRT, square root of that number, close the parenthesis. So you got the square root of that number, which is 9.37%. So let's look the formula. We need everything. We need to calculate the Sharpe ratio. So now I'm going to calculate the Sharpe ratio equals to RP minus RF. Let's do the parenthesis. Okay, RP is return on the portfolio minus RF is given in the question. You divide by standard deviation of the portfolio, which we just calculated. Okay, all right, here you go. So we got the solution 0.0057. Okay, which means if you round up to 2 decimal, remember I want to round up my answer to 2 decimal points. If you round up to 2 decimal, is 1.01. So as you can see that the solution for optimal risky portfolio, the Sharpe ratio is the same. Either you use Excel versus you use the formula, whichever you feel comfortable, please use those. Okay, but I prefer using formula because this is a lot of work here to be done. If you make a small mistake, you're going to have a wrong solution. I hope this video will help you to calculate the optimum portfolio weights, and using those optimum portfolio weights, you can calculate the Sharpe ratio. Thank you.